Oh, it's because of your driving.
I know it's just good.
Oh.
Yeah. Yeah, it was like. Wait, no, Judy, you're right. And then
Yeah, so you're right there.
It's just.
Yeah, that.
Wait, did you get?
Yeah, I do, yeah.
She looks wait, Lee, because
In the, in the adult
she looks at things like.
would be 0 2.
Yeah, she didn't have read that. Teacher. He's not into teacher music, that's really.
You're actually like starting to.
Yeah.
You're starting to. Stop. Oh, you can't. That's like, that's like. It's like a. I know it. Oh, you did multiple.
Same word.
Basically, somebody straight wash.
I mean, actually, well, yeah, it's.
Yeah. So.
Let's go.
Alright, what's that? Alright. Alright, you know where this is.
Oh, for this one? Yeah.
Okay. Ready or not, let's just go over them and see how it is. We have a lot to do today. Now, if you liked last time,
I missed something.
right, Jonas, if you liked last time, you were gonna love today. Yeah, yeah. Now, if you didn't like last time, you are going to love today. Don't worry about it. Just enjoy. You might double love it. Who knows? What's that? You double disliked last time, is that what you're trying to say? Oh, that's a good joke. Is it opposite day today? It seems like it might be.
It is good.
Number 1. What happens when you take the square root of a number that is between 0 and 1? Yes, Oliver. How do you know this?
Well, the square root is number that when you multiply it twice gets that number, right? So when you multiply a fraction by itself, so it would be a fraction times a fraction, you get like, we're gonna say fraction too many times, but you get a fraction times a fraction, so it's smaller. So that's why the square root of it is not square root.
Okay, so you know that in one direction it gets smaller, so the other direction is going to get bigger. Okay. They want to do that a little differently. Do we agree that it's right, that the number gets bigger?
I agree.
Yeah. Did you want to tell us what you did? Something like. Let me see. The controls are in the way. This is nice. I love how you did that. So you visualize this in your head kind of thing, or did you draw it out?
In my head.
Very nice, yeah. I think you're right. The answers are all here. Like this line here is just y equals x. Right, it's a little bit skewed. So if you just plug in a 1/2, of course, 1/2 comes out. But yeah, when you take the square root of this number, it is bigger than that with which you started. Did anyone do like for instances in your head? Like the square root of 1/4?
Oh, I did like.
Is 1/2, right? It got bigger. What did you do?
I took two fractions and multiplied them by each other and saw that they were smaller. It was like 1/6 times 1/6. That was 1/6.
Nice. Okay, so then you reverse that.
Yeah.
Okay. Do you know what the square root of 1/2 was?
1/8. No.
So, we don't know square root of 1/2, but we know the square root of 0.49, don't we? 0.7. Does that make sense? So you got considerably bigger. 1/2 becomes 0.7. So yeah, they're all getting bigger. So just a little number sense for you to start the day. Next, a circle. Now this is my way here. Yay. Circle of radius b has a center located at 0b. Write the equation of the circle in rectangular and polar form. Now, I was thinking it would be kind of fun to give you numbers 2 and 3 as a pop quiz. Wouldn't that have been nice?
That would have been.
Now, I don't usually do pop quizzes, but why would that have been a fair choice for today?
Because
You didn't know that yet last time.
Yeah, those problems were on the homework. So hopefully you handled this already. It may be a little bit different from what you saw in the homework, but yeah, the Pearson.
Isn't it due tomorrow, April?
What?
It's always do the next class. So the one, oh, did I say 10th? I'm sorry, that was incorrect. But yeah, it's due the next class. It's due the next class. So just because I'm not sure about the judgment of waiting until after the following class, but in general, it's due the next class. So who'd like to help us with this? Yes. Okay.
Okay, well, we know that like the normal form of a circle or rectangular is x minus h squared
Okay.
plus y minus k squared equals r squared.
Okay.
And we know that here, we are given the center at 0, b, and we also know the radius is b. So we can plug that in by doing x minus 0, or x squared, plus y minus squared equals squared.
And we're done with that, aren't we? That's rectangular, isn't it? It's X and Y. We're done. Yeah, thank you. Halfway done, 50%. Much better than 0%. But how can we make this in polar form? Dun, dun, dun. And yeah, help us out.
So I tried. I looked at the notes from yesterday.
Okay.
So shift, circle, and a coordinate plane on the y-axis. Or I guess that's not an axis.
So you visualize this, right? It sounds like you may have visualized it. Okay.
Thing.
Oh, okay.
And so I kind of took that sample equation that we did, which I wrote down as like r equals 4 sin theta.
Okay.
I saw that the highest y value or like value is 4, which means that the middle of the circle would have had to been 0, 2.
Okay.
So then I thought of it and I realized that it would have to be written as like 2b sine theta.
So you use what we did in class to kind of build off of that to get the answer is what I'm saying. What do you think? Does that make sense? That is the diameter, yes. But yeah, I'm gonna help you build this in just a minute, but that was really nice. Thank you. Any other input about how to get that r equals 2b sine theta? Yeah, let's expand the binomial. X squared, does it, when I say expand the binomial, do those words make sense to you? We got that y minus b, let's expand it. So we have y squared minus 2by plus b squared. I hope that's very easy for you to do. Yeah, b squares. You say adios to them. Thanks for coming. Nice to have you. And yeah, let's move the 2by over. And this form is called still rectangular. It's x's and y's, but it's cleaned up a little bit. But how is this helpful? We know x squared plus y squared is r squared. And that y is r, it's r sine theta, isn't it? Yes?
Right?
Y is equal to r sine theta. And yeah, so this form is called polar form. But it doesn't match what Nia said. It's really close.
You can take the r.
I'm not going to divide by r because it's a bad habit to divide by any sort of variable. Instead, I'm going to subtract that 2b r sine theta from both sides. R squared minus 2b r sine theta equals 0. And next step, I'm going to factor out the r. And now we see something that looks exactly like what Nia was saying. It's like she's from the future. She knew it already. And we have two choices, either r equals 0 or r equals the other stuff. What do you think? The other stuff, it actually has a radius. We're not going to use r equals 0. So we're going to exclude that and just say that r equals 2b sine theta. What's that? How do you test for answers? From our knowledge of this, like if I say r equals 2, what graph is that? R equals 2. Could you all show me the graph of R equals 2? R equals 2 is a circle that has a radius of 2. So R equals 0, can you show me what that looks like? So it's just not that. And because this is a circle that actually has a non-zero radius, so we dismiss that as extraneous here. Yes.
Why couldn't you just divide by R?
It's just a bad habit to divide by variables. It'll work. It'll work. Yes.
Plus y squared equals 2by hat.
Well, what is x squared plus y squared equal? Okay, now what does y equal? R sin theta. So it's literally just rewriting pieces that are there. Yeah? We like? Guten Tag, yeah. There is an answer to the question we like, by the way. When I say we like, do you know what the answer is? We love. With passion.
Crack the code.
Yes, Emma, extra credit for you. Okay, identify the graph. Identify and graph the polar equation. What's this?
Theta.
Are you sure?
Yes.
Someone in my last class asked, what is that? Read a little bit more. Said, who can help me with this? One person who hasn't spoken today gets first chance. Yes, close the king. Okay. Yes. I like that. We probably could have just jumped right in there. But yes, thank you for showing us the steps. I'm picking up what you're putting down, Chloe. I really like this, okay?
Multiplied R to 5, so I did R squared equals and R squared.
What was the reasoning behind your multiplying both sides by R?
To get the R times like.
Yeah, it's taking control of the situation. So that's 10x on the other side is x squared plus y squared. And now we finally have this in rectangular form. So why did you do this? To graph it. So from here, did you change the form? Like you move that 10x and then you complete the square. Does that seem reasonable? Can you give us the final form, please? Y squared plus y squared equals 25, you said? Thank you. That's really nice. Okay, so when it says identify the graph, you can identify this as a circle with radius 5 and center at 5. Negative 5, 0. Is that negative 5?
Yeah, wait, why is it x minus?
Oh, it should be minus, shouldn't it? I think I miscopied, but I think you had said x minus 5. Because that 10x became a minus 10x when you moved it over, so x minus 5. Oh, that was great. Yes.
Can you also do this another one?
How would you do it?
You can make like a sine, a cosine graph.
So just from here, kind of make a cosine graph that does
and then
this.
graph there.
So just graph like how we did last time, graphing a polar. Would that make sense? Because here, this is what 10 and negative 10. So does that do the same thing? It starts at 10, goes. Does that do the same thing? Yeah, it does the same thing. So however you want to do it, do it. Let's do it right. Thank you. Oh, that was a good one. That was a good follow up to that.
Yeah.
Do it right. Don't do it wrong. Yeah, bumper sticker in creation here. Any other comments on this one? Okay. Today, ladies and gentlemen, you ready? You want to put in your seatbelt? We're about to go for a ride. We're about to go for a ride. You have your helmet? Oh, you didn't bring it? Oh, you're a reckless man.
Smile when I get excited.
Oh, but you're always excited about math.
I see.
Okay, let's go back to the packet. And I'm just gonna say, have fun.
Oh, is it like that one like?
Oh, don't give away anything. Jonas, I love that T-shirt.
Oh, I think we did like this one problem. No, wait a minute.
I try to understand the other two, like,
Hold on. Yes, I didn't know that. No. This right up here. Just have to. Oh, no, stop.
What's the scale you did on Y? You made 2. I think that is Y. Is that was really nice. Thanks, Jonas. I don't know who you're talking to, but that was really nice. I appreciate the positivity.
Oh my gosh.
yo, I literally.
Oh, wait.
Yeah. I think I kept. It was just so like that. It's like two months.
Go back to 2. What the hell?
Yeah. No, you know what I meant. How did you know?
No, you can't go.
You're in a.
Just go back. Go back to 2. You go to 0 and then you go back to 2.
But back over here goes to that.
But negative 2 is negative.
And then so it would never ever like that.
Just stay 0 and then you take 0. You like to 0.
Oh.
No, it's at pi. It starts at 0. It starts at 0. That's where the negative. But it's,
Yeah, I think we're.
yeah.
6 to 2.
You're Is that it? Is that it? It's a little bit
Yeah, it like goes to like. Wait. Stops at 2 and then like.
It is like
Like, it
It's
doesn't
maybe
cross
on
an
the-
S and it's I don't know.
I thought it was gonna go to zero.
Yeah, that's true.
It's a new saving. Yes, that was, yes, I didn't want to say that.
I got hired. So what if
I'm gonna ask for your attention about 15 seconds. Oh. And at the same time, I'm going to look.
What if we back?
Mr. Lieber,
Yes.
am I allowed to go like 2-0 on like on a quarter in a row?
Are you able to win?
Like if before it goes to the negative,
did I get a
could I go from like 2-0?
Maybe, I'm not sure. Okay, so let's go over this.
Negative.
10 seconds to finish up. For now, I'll give you some time to figure things out in just a moment.
Is that a heart?
5, 4, 3, 2, 1. Okay, everyone's attention, please. So, did you find the first quadrant pretty easy?
Yeah.
Yeah.
Because the radii go from 6 to 2. So just in front of you, you start at 6 on that 0 and then goes into 2 like this. Then you got to turn as you're doing that, right? So 6 to 2. So that's what we start with. So I hope that you did something like, oh, what is this? Oh, it's 1, 2, 3, 4, 5, 6, and then you end here.
Oh, I did.
You have those 2 points?
Yes.
Should I just make a line to it?
No, curve.
It kind of,
It's curvy.
it curves to in fact. Let me see if that's what I did. First.
You say
What is it? It's on the y-axis instead of the x.
Say that again.
Like, what's the reason why there's left on the y-axis?
Well, but remember, as theta starts at 0, then turn this way. So when theta equals 0, r is 6, so it has to start here. And then it has to continue along this.
Oh my god, there's still points.
What's that?
Because there's still points.
There's still. Okay. All of
Oh.
Now, I'm not gonna go from pi over 2 all the way to pi because it becomes negative. That's too much to deal with. So instead of going from pi over 2 all the way to pi, I'm gonna go from pi over 2. Whatever. Do you know what that point is? Can you figure out what this point is right here?
Oh, yes.
Could you calculate that, please? Take a moment. With your hand. Calculate. So
Wait, which one?
this point right here. This is called a
Oh, 0.
0.
Oh.
And you set that equal to 0.
It is, it's 5 pi over 1.
How'd they do that?
Theta equals -2. Cosine theta equals -1/2. Is this difficult to solve?
Yeah, man.
Okay, I forgot.
We gotta do cosine theta equals.
Gotta do negatives.
2 pi over 3, is that the only answer?
I got 5 pi over 8. 4 pi.
So theta equals
5 pi over
2 pi over 3 and
4 pi over
4 pi over 3. Do we agree?
Wait.
But it can only be 2 pi over 3 to 4.
Well,
Or well, I guess those are both the 0.
This is
that
2 pi over 3
pi, yeah. No.
And this one here, it is 4 pi over 3, which makes sense, but then right in the middle is
I mean,
pi.
I guess.
It's, I hope hopefully it balances. So instead of going all the way from pi over 2 to pi, I'm gonna go from pi over 2 to 2 pi over 3. In order to do that, I'm going to put a dashed line. I think this is 2 pi over 3, isn't it?
Yeah.
So in this sector, the radii are going to go from 2 to 0. But it's got to be in that sector. Notice I'm going to respect the boundary of that. There. So far I've gone from 0 to 2 pi over 3. Now, before I do the rest, I'm going to see what happens when I'm at pi.
Go back up to 2.
The radius is
2.
Negative 2.
radius is -2, isn't it?
Yeah.
Which means I'm going to have a point right here. Does that make sense?
Wait, why?
Oh my god.
Because you're just.
Right, when theta equals pi, r is equal to -2. So the point is -2 pi has to be on this graph. Are we good so far?
Yes.
Oh, yeah. From 2 pi over 3 to pi, all of the radii are negative. So in this little sector here, I'm going to see nothing. Does that make sense?
It's gonna be in the fourth quadrant.
Instead of being over here, it's going to be in the sector that is vertical to this. Does that make sense? Like vertical angles, which means I have to
Yeah.
continue this down here. I'm gonna so anything from here is gonna be expressed here, going from 0 to -2. Do you see what that's about to look like? I'll give you a minute. Keep on going. I want to see some good stuff. Oh, it's gonna be like a. Oh, it's gonna be like a. I want to see some good stuff.
Wait, so.
Might be -2 pi. Something on the other side.
It's really not. You say that, I like that. But I don't know what to.
Oh, wait, like there.
Wait.
I thought we already did that.
Oh, wait, no.
It's so hard to see.
Go through this.
Does anyone have it?
I have
Fairly
it.
finished?
I
Well, okay, now you're gonna take
Yeah,
when you're 0, right?
But, so we already did
0 to
it.
2. Going from 1 to -2, 0 from 0 to 2, right? Like,
Okay, so from that to
from 0 to 2, right? Like, where is that?
Here.
And where's the 0 and where's the
Oh,
2?
sorry. Here.
So we know the 2 where's the third?
So what is
Third
it?
quadrant.
So you have to go like curve down.
Yeah.
This
is all the positives.
It'll be like.
You hear Dr. But look at, right, look at where the halfway point is.
Are we ready to
3 pi
continue?
over 2 is, right? We're dealing with
And you
it.
divide it into thirds.
Miss Oliver.
Why did you, do like, how did you know to go to like 2 pi, you know?
That's where it stops being positive and begins being negative. So that was the 0 of this function. I set it equal to 0.
So like, you have to graph this from and when like.
You have to find that theta. Yeah, exactly. So notice I didn't like pass that to do this. I stayed within that sector. Okay, and now in this sector, because this is vertical to where we actually are, the radii are going to go from 0 to -2, aren't they?
Yeah.
So that is right. Is it here? Here. Let's make sure this makes sense. I'm talking this in a little bit as you perfect your graphs. I feel like you guys want to finish.
So let's go, so 2 to 6. Yeah, 2 to 6 is 3 pi over 2.
You can't make those values.
Can we continue?
Yes.
First of all, if I get everyone's attention, and I'm sorry to interrupt your progress, I appreciate your word. One moment, please. I want you to just see that we are going from 0 So we're going from 6 to 2 to -2. Do you see that? 6 to 2 to -2. We've done exactly this. And now we have to go from -2 to, oh, what's my boundary?
2 pi over 3.
I already had 2 pi over 3. 4 pi over 3. I think that's right here. Is that right?
Yeah.
We take a moment to just appreciate the unit circle, how great it is.
It's the best.
Yeah,
We love you.
me too. Thank you. Okay, so these are all negative in here, so I'm not gonna see any points here. Instead, I'm gonna see the points in the sector that is vertical to that, going from -2 to 0. But after 4 pi over 3, we can now go back to this. This is our 3 pi over 2, is that right? So there's gonna grow right to that.
What?
Huh?
Is that what you already have?
So confused.
Yeah.
It's so. Wait, I didn't have the whole thing in the
And
middle.
then
I see this graph.
from 3 pi over 2 to 2 pi, the radii will open up some 2 to 6. 2
This is so hard.
to 6.
Oh, man.
And after that, what's gonna happen after 2 pi?
repeats.
Or, so I can stop here. Yes, yeah.
If a point is the x-intercept like on math graphs, it's always just gonna be at the, we call it not the origin, but
It's gonna be a line going through the origin, the pole.
yeah, but like it'll always be like a point on the pole, so if you need to like encapsulate 2 pi over.
Yes, because I wanna see, and I did a little bit for you here. I wanna see that you're adhering to that boundary at 4 pi over 3, the rest is coming out after
You
it.
should always draw the dot line.
Yes.
Wait, where are you talking to?
And Judy,
For the points between 2 pi over 3 and pi, would you say that it's reflected onto the guide?
between pi over 3 and pi,
2 pi over 3 and 1.
oh, when I say it's a reflection,
Is it with reflection of the
not a reflection, I just said that. In here, in this little region, all the radii are negative, so it's coming out the back of that axis. Remember, every axis has a positive and negative, right? X-axis positive and negative, Y-axis positive and negative. So here is really easy because these radii are positive just in that direction until we get here. After that, that's gotta become negative. To -2. That's what's happening, they become negative. I know. Max,
I'm still a little confused. Why do we have the dotted lines? And why can we like cross them sometimes but not cross them every time?
you mean like right here, why can we cross it?
Yeah.
Because this has nothing to do with the 0, this is going from, this is going from pi over 2 to 2 pi. Pi over 2 to 2 pi, we crossed 2, so we were able to. It just had nothing to do with that boundary. This had more to do with what's here.
Yeah.
I'm gonna do it one more time. Everyone, put your pencils down, just take a look. In pieces, this is from 0 to pi over 2. I stopped briefly over here. Because the radii became 0, and now I'm at pi, they went over here. So this little piece had to be within this boundary, that's what this is for. This really is not necessary. We could erase this for now, we don't need that. Oh no, we did need that, didn't we?
It shows the from the
Yeah,
0
but
to
this is contained.
pi.
Contained, so that this is inside that. We needed that for that.
Oh, so that's for.
The 0.
That's for the negatives. Right, I didn't come down here. After this, it's still negative, but by here. They become 0 again, and then they become positive.
So that's from 4 pi over 3 to
Yeah.
3 pi over 2.
Yes.
Or
This is got to be. Okay, so we do have more to do. And I think as we continue, you're gonna understand more and more about it. This makes sense. This is a new shape. It is called. This.
Limicon?
It would be a limicon, except that it has this little tail on the C, so it's a limaçon.
It's
From what language?
French.
French, limaçon.
Remember they got cool. Oh, okay.
Limaçon means
Another one on the next.
snail.
Wait, I thought.
Ew, that's gotta go.
Yeah, I think that's what you eat. No, not you necessarily.
Third graph.
Let's move to. Let's see what's next here.
Alright, please.
We're not gonna do C, but go on to D.
New shape.
This needs a lot of understanding.
Hi.
Time for D.
Hello.
You say D, you said D.
D. Skip C and do D, please.
Oh my God, here he is,
Yeah.
here. My goodness.
Two five over two.
It's too far over here.
Mr. D, two five over two.
It's Maria.
Yes.
Half and five is barely.
I think there's some in the bottom there. Okay, let me help you with the scale here. Yeah, what's the period? Thank you. That's the first thing. 2 pi over 3, and we're going to label that right here, please. This is 2 pi over 3. Notice how many I've chosen to go? I'll explain in just a minute, but for right now, I want you to trust me and you'll see why. Oh, sorry. So I want the fourth one, and it's the fourth one because every period has 4 parts. So that'll be the easiest way to actually do this graph. It could be anywhere, but this is my recommendation. What unit are we going to put on the y-axis?
6.
Yeah, let's just make it 6. Let's make life easy.
Oh.
I don't want to go all the way up.
That's pretty.
Okay. On the polar grid, I do want the units to be, or the scale to be 1. So let's see what you can do.
Do you want to see on flat stuff?
For the helper graph, I want the 6. It's just, well, that's great. I'm just being lazy. Are you gonna go all the way from 0 to 2 pi? I said 0 to pi over 2. Would that be a good idea to go straight from 0 to pi over 2?
Don't you wanna break it up?
Yeah, definitely break it up in a way that makes sense.
0. 0 pi.
Yes.
Oh. But why don't you go past the horizontal compression? Why can't you go past this?
Is there ever a time that, oh, I was. It's
You're back.
I'm back. So that's on access. Oh, so yeah.
Wait,
Oh.
pi over 3, wait. Pi over 3 is right. So I have to go back. It's like that.
But why do you do it?
Oh, yeah.
Uh,
So far.
Yeah.
Now we're back. Oh, now we're at negative. So then it just repeats.
Okay,
Wait,
6 to
wait,
0,
no.
so
No, because look,
6 to 0 goes from pi over 6 to pi over 2, so yeah.
Here.
Wait.
No, but negative 6 foot. Oh, wait.
Wait, do you have to go in order of the Yes. Okay. Wait, oh, isn't it 6 to 0?
And that.
Are you sure I missed it?
Yeah, so it's
Zero.
I didn't do the rest things, but I was still here. I was like.
Yeah, I got to pi over 6. Here.
The left.
Because 6 to 0, right?
Oh, yeah, right.
Yeah.
Finally, I was right.
Oh, yeah, they go whatever you say.
Wait, I'll do it and I'll explain it, cause I wanna make sure.
That's not fine.
Like,
Okay, and then pi over two. Okay, so then L, 0 to -6. So now we're in the third quadrant.
Yeah.
So 0 to -6. Okay.
Same thing, and we're coming back to zero.
So we're here, we're here, we're
It's
here.
like,
We're going up here, we're going up here. Wait, up to here. I would do it here.
Over this axis.
So it needs to,
Yeah.
so we're assuming the original is over.
Wait, Mr.
here.
Lee,
Right, this one, no, we're assuming.
I'm over here,
Going.
where I'm going from here to pi over two. Can I go from all the way up here to here?
This is the, right?
I'm not sure.
And so whenever.
You're going from where to where?
From pi over three, so I got to here, like this is where I'm
I
at.
can make a dash line.
So if you want to
Yeah.
mirror it, you have to go across.
Oh, we did that.
Don't go straight on.
Make sure
Then
you're
go
following
straight
it
down.
correctly. 'Cause I don't think that's
Oh, wait,
all-
two
that's all.
What are you talking about?
So you're right, you're right.
Ready to.
Oh my goodness, you're right.
And I don't.
Sorry.
3 is.
I think it's both. Don't worry.
So that's gonna
Okay. And then now what?
Oh,
Now we're at pi over six. And now we're going to two pi over three. I don't think.
This is pi over 3, this is 2 pi over 3.
Right.
Okay.
So now
pi
we're
over
like, I don't know. what
pi
I'm
over
gonna
two.
do.
Wait, why are there so many lines?
And from there, we're
Right.
going. to
Here,
over-
here.
Wait, what
Okay.
are each of the lines?
Negative
Middle one's pi over 4. First one's pi over
I thought
6.
we did it wrong. It's pi over three is here. This
So
is
now,
middle three.
oh, now that means.
What?
So then this is pi over three, yeah, that's pi over
Oh,
three.
six.
We're
Which-
going now.
And then this
So
is
it's
pi
like
over.
this. It's only that. Wait, actually.
Then-
Yeah, okay, so wait, we're up here.
Wait, here, now we have to go to pi over two. Wait, so then,
You know, Flickr.
Are you about ready?
no,
I haven't seen what's going on in this corner.
oh my god, I got it.
Helping me
Yeah,
understand.
up to there.
Yeah, back.
That's not.
So then it was 0 here, and then it was
Because-
6.
Okay.
Then we go
I think when we were under the ground.
So it's,
there.
wait, you agree, yeah.
And then pi over
And
two,
then
two
from
pi over.
basically down, it's probably start like you're going to zero to eight.
20 seconds.
Wait, I.
Well, I get to call them pi.
Make the bounds.
Oh my god.
What do you?
Wait, someone, I got it.
Would you go to pi over two?
It's like this.
I like.
Ready or not? Let's go over
It's like
this.
Huh?
No, I know, we've already established we're not gonna go from 0 to pi over 2, right? That would be
That'd be absurd.
right here, and that's just weird
It's
because it's
negative.
positive and negative going on. So let's go from 0 to
I over 3.
how about a pi over 3? What do you think? Just keeping in mind that at pi over 6, we have to have a point, don't we? Now, do you figure out where pi over 6 is here? How many tick marks do I need in the theta? Yeah. Because each one is pi over 12. Yes, we have 1, 2, 3, 4, 5, 6. I'm going to put this here at pi over 3 because that's where one of my zeros is. And now just from 0 to pi over 3, the radii increase from 0 to 6 and back to 0. So it's something like it's a 6 and then to I just can't.
I think it's like this.
Gotta be nice and even.
Does it have to approach the line as much as it can? Do we have?
Want to be contained there. Honestly, I don't care how thin or how fat it is, as long as it doesn't go past that much. Yes.
Is a good like rule of thumb, like when you're drawing. Okay, so like technically there'd be a boundary like on the x-axis, right?
Yes, that's 0.
So like when you're going from like 0 to pi over 6, you have to go like towards the boundary. Like that's how you know it's all like this. That's
Maybe, all I'm thinking is I have a theta starting here at 0, so it has to increase to 6, so it just kind of increases.
Oh,
wait. And then it
Decreases to 0. So from here to here.
Yeah, cause I wasn't sure if going from 0 to pi over 6 is really that way.
Yeah, it's definitely like this.
You're at 6 and then 6 and 0, right?
My next key point is at this, where I have pi, what is it, pi over 2?
Yeah.
Comma,
Oh, wait, I'm saying negative 6.
Negative.
that's actually -6 comma pi over 2. So where is that?
On the third,
Down.
or like.
It's
goes
flipped straight down.
across.
It's down here, isn't it? 1, 2, 3, 4, 5, 6, So from pi over 3 to 2 pi over 3, did you have these dashed in yours?
Yes.
Nothing's gonna be up here, it's gonna be in the sector that is
Opposite. Inverse.
was it
Or across.
vertical to it.
Oh.
So I'll extend these lines. So it's gonna go, do you see exactly where it's gonna be next?
Yes, like a pedal.
So it starts here, yes,
It goes back up.
except I did a poor job tonight, I went outside my boundary.
Uh-oh,
Yeah, oh is right,
But just a bit.
I know, but it's a bit,
a bit too much.
Simmer's like a bit too much,
Sorry.
yeah. Yeah, you're right, I have to be accountable for when I'm. Oh, you count, it's still, it's marked, excuse me. And you see what's gonna happen next, don't you?
It's gonna go back.
Then it goes back to 0,
Wait, do you just draw a boundary wherever? Like,
at the zeros.
oh, 0.
Yes, we got it?
What is the reason why we extended the boundaries for this one, but not for that one?
Extend the boundaries, oh, for these, we extended for all of them. But when I was going from pi over 3 to pi, that 2 pi over 3, there's nothing there. It's in the sector that is vertical to that, so it's in vertical lines, you have to have lines that intersect. Oh,
Like
I think-
he extended it, but it's one to do.
but the curve was actually, giving the boundaries. Similar than Haley.
Wait, so you extend it like throughout the whole graph just because it's easy if you're going, and is it actually smart to like start withdrawing the boundary?
I think it's a really good idea.
Okay, wait,
Yes.
is it stupid, but our boundaries on like the axis line or on the midline?
Wherever there's a 0,
So on the 0.
the zeros,
Us-
yes, Haley.
The boundaries only apply for like when you're going from one point to another, like say you're going from pi over 6 to pi over 2, like then you have to follow the boundary pi over 3,
Yes, exactly.
but then nowhere else.
5 over 6.
So I need that boundary here to say, oh, one
Yeah.
over there.
Then that boundary would kind of only apply when you're double.
Yeah, it just applies to this region. Really.
Yeah.
Yeah, that's a good question. Are we done with this problem? The question is, if I were to continue, would it just do the same thing?
Yeah.
Let's see, is there another component? Let's see, from 2 pi over 3 to pi, is that right? It's opposite. 1 pi over 3 pi over 3.
But how do you say it was 6?
Once it repeats over itself, then we're done.
Oh,
So to all the way to pi, it's going to, let's see where I'm at. So in this sector, from 2 pi over 3 to pi, it's going to hit 6. 1, 2, 3, 4, 5, 6. Then come back down. There we go. There's one more. And if I were to continue, would it make another loop?
No. Makes
Makes the same loop?
We've hit all.
Yeah, after pi, I think this is 3 pi over 3 to 4 pi over 3. So here to here, all those r's are negative. We've already done that. This has a special name. I think you may already know it from the homework. You know what it's called?
Rose.
The Rose. I think Rose had a hit song last year.
Oh, yeah.
Is your middle name Rose?
It might be Rose, or maybe not. You'll never knows. This is called the Rose of Free Petals. Rose of.
Lieberman. Lieberman. Barry wrote a cat in a nail. Happened next.
Oh, I don't know.
Barry Road.
Try the next problem.
Wait, you believe it? Barry Road, cat in a nail. What happened next? Barry Road.
SAS.
What about this?
What?
What am I missing?
Mary Rose cat in a nail. After that, Barry Rose. She wrote.
Oh, that's nice. Oh, that's periodic.
Wait, but why a nail? Why not just a chair?
Sit on a nail. You're not gonna say that.
Back.
Oh.
We got it.
Well, why not like a pie? Like I sat on a pie or something.
Why would you sit on a?
No.
You guys are looking on E, correct?
Yes.
Hey there. Wait, actually, super.
Is that your brother?
What?
Is it?
Yeah, we always.
Hello again.
I didn't do anything.
Are you saying hello to your followers?
All my followers out there in TV land. Oh. Those counts.
I would also.
Equals 5.
Oh.
Period. Hi.
So, yeah.
I'm so fast. It's like a butterfly spread. I came out of this. Oh, crap.
I'm drawing like zeros first.
I like that.
Yeah.
Yeah, these zeros are actually good math. Okay.
I'm too high. Wait, it's so nice. I love it.
Okay.
Really six.
Wait, is like the number inside?
Maybe. Yeah, there is a relationship.
Favorite
Oh, I don't. That's it. That's crazy. That is it, right?
Yeah.
No, okay. Now 6 to 0 now, ready? 6 to 0. I'm gonna go to, oh my god. Wow. Look at this.
Wait, pretty.
Pi over,
You're doing great.
pi over 2.
Just a
Pi-
I need it.
Wait, but now I'm in the next, right?
Yes, you're gonna go.
Okay, I'll read lost it.
About one more minute.
It's not good. This part, wait. So pi, ready? Pi over 2, 3, pi, so, okay. Wait, so wait. Wait, okay, so 0 is. Where's 3 pi over 2? Wait, 2. Here. Wait, what? The 6, right? And then 6 to 0? Yeah. 6 to 0? 6 to 5, so negative. Okay, wait. So there, yeah.
Right? Yeah, I think so. I did it, Sheila. Let me choose you.
Okay.
Retro.
I got 4.
What's this for this one?
Sinusoidal.
This episode. This is 5?
Yeah.
Yay.
That's too high.
Okay, so this is 5 or 2. So in the first quadrant, radii I go from 0 to 6,
0.
back to 0.
0.
You did something like this. 1, 2, 3, 4.
Peter,
five, six.
Pepper.
This,
Peter.
Mathematics in there. So the second quadrant,
it's gonna go.
nothing's there.
It's
Right?
gonna
You
go.
made exactly 4th quadrant. Hitting 1, 2, 3, 4, 5, 6.
It's so.
Third quadrant, 5, 3 pi over 2. It's back, isn't it? 1, 2, 3, 4. And then finally 1, 2, 3, 4, 5. And the
Just write
motion,
flowers now, guys.
Love drawing.
the motion, this probably brought to you by Miley Cyrus, by the way.
Can
Goes
you
like
give us
this.
a
There you go.
Having a little like.
There we go.
I used to draw the like shapes all the time.
Jonas, can you stand up and show us your t-shirt, by the way?
Buy yourself flowers.
Perfect. Jonas, if people at home could see, Jonas.
Romantic.
Camera here.
We should draw like 5 ornaments.
Jonas is more in the shirt for today. So like, thank you, Jonas.
My nation is
Maybe I'll have you do that.
things I don't understand.
And then make our own opinions and then all.
We had to finish one more. One more.
Video.
Hello.
I think we should make our own equations, and that way we can all have really pretty flowers, and we can put pretty colors.
I'll submit it to the committee. Thank you. We got to do this one. We're doing G. We're doing the next one. So we're doing F. There's no G. This one. I'm going to change this a little bit. I'm going to take away the 16. Yeah, I'm sorry. So in this case, oh. As I make this so abbreviated, but we are close to done. This ride is longer than I imagined. What am I going to do to both sides? Take the square root of both sides. So R is equal to, what am I going to start with? Plus or minus the square root of sine of 2 theta. So I actually have two equations that I'm graphing here. This one, sine of 2 theta, and R is equal to negative square root of sine of 2 theta. But do we know what the graph of sine of 2 theta looks like? What's that? It's gonna look, we're gonna start with start with 2 theta. I'm sorry, what's the period of this? What's the period? It's pi, so I'm gonna put a pi right here. And I'll put a 1 right here, just to give myself a little bit of room. So this is normal sine of 2 theta. Yes?
Whoa, that's nice, y'all.
Thank you. So this is R equals just sine of 2 theta. Now, if I take the square root of a number less than 1, what happens to that number? It gets bigger. So do you see what that hump is going to look like? It's going to be a little bit more rounded, except that 1 at the top is going to stay right there because the square root of 1 is 1. So it's going to look like this. Something like that. And how about the second half? What's that going to look like? What's the square root of those negative numbers? Does not exist. Yeah, they're eyes. So we're not going to graph anything from pi over 2. Everybody say hello to Mr. Neelis. Thank you for visiting. And I'm going to do one more just for funsies right there. So let's graph that. 0 to pi over 2. I'll put my 1 way out here because I want to have some fun.
Wait, can you explain again why it's like thicker?
Yeah, the square root of a number less than 1 is more than 1. And I took the square root of the sine. So I'm just trying to get an approximation here. Really what I want you to know is why there's nothing between pi over 2 and pi.
You didn't work this next spot.
This is it. Yeah, maybe we'll do a little practice, but we'll see.
Well, tomorrow, yeah, so that's my quiz.
Okay, next is next time we do have our quiz. Thank you. Pi to 3 pi over 2, what's it gonna look like?
Nothing.
No, from pi to 3 pi over 2.
Oh, it's gonna be like, pi.
Gonna come out here and do this.
Yeah, no.
And how about the negative one? Well, negative is just, I think it would be this, wouldn't it? I think we've already graphed those.
Oh, so it's just.
Yeah, it's just repeated. Yeah. This shape has a special name. It's called a lemniscate. you have to be able to recognize them, for sure.
Like if
And for
you
the
ask me
homework.
to draw them, okay? Have to be able
You should be familiar.
Negative what?
They're both the same distance. Yeah, this is just a me tracing.
Oh, right.
Here it's just going to go over. It's also called a figure eight.
With this. No.
It has boundaries here and here from 0 to pi over 2. Sure, yeah. But I'm not doing something like this. Also, I'm not going to do something crazy like that. I stay within those boundaries. I do want to show you one more thing. Has this been enjoyable? A good challenge? I love these. I don't really like math, but I just love math. Yeah.
Oh, yeah.
I know, look at this face, shocked.
I was scared.
It'd be nice to see this on our calculator.
It would.
Oh, I know how to do this.
Things are getting calculated.
I think I left it in physics.
Oh, no.
NGL.
If we don't have a calculator, could we use better?
No.
That's can't do
You
this.
can do those ones.
Wait, can definitely do that?
Yeah.
Plus this, Scar.
Yeah, I know, it's like double.
Okay, first of all, how are we gonna put in?
Mode, polar.
Yeah. Does someone want to use a calculator?
Make these.
I wanna know.
Yeah.
Always. Wait, Mr. Lieberman, can I plug in? Okay, I'm ready.
I think you just have to watch because there's almost no time. Okay, so right now it's y equals, how am I gonna do polar? Alright,
Anyways, no, we just grab.
we're gonna mode, do you see where polar is?
Mode.
Wait, how do you do that?
Whoa, thick? Would you make it thin?
Function, polar. And y equals, I did this one, 6 sine of 2 theta.
Wait, you did polar and what else?
I just put polar and then the y equals. So then I can put that one in.
Mine has a hole in it.
Doesn't
I went to mode.
I wanna do something about that.
Yeah, maybe.
On the right.
Okay, so I'm doing this one, if you wanna join me, 6 sine of 2 theta.
6 sine 20. No,
Use the R.
How do you take that?
Yeah, how do you do theta?
Right?
Yeah, x and theta are the same, but.
Oh.
Oh.
And then when you graph it,
Wait, how do you get theta?
it's the x button. Yes.
Found that zoom fit works very well for
Oh,
us.
zoom fits. Let's do zoom fits. What's it gonna do?
What?
Gonna fit it.
It's gonna fit it.
So how do you get theta?
Gotta get in to fit it.
Whoa, so fast.
Wow.
One more thing, it's kind of skewed because it's going 5 in each direction-ish. I wanna see if the x and y is even, so what I'm gonna do, take a look at this, I'm gonna do a zoom. Square, right, zoom square of 5. Now, all of the axes have the exact same scale, so you can see exactly what it looks like.
What did you press?
I went to zoom square for 5. And so it makes it nice and even, everything is perfect.
Oh my god, this person messed up the domain.
So, if you wanna do a couple more,
Mine's just a.
you have a minute to do that? Wanna try?
Wait, when you
I did 6 sine of 2 theta.
2 theta.
Okay.
Like, if I press the ground.
Do you put a theta in?
They got it.
It's a delta.
Could be a defensive day of color name.
So there goes this. This is dots.
So Leland, I have a question for this one. Does the square root also change the one that is the way the floor should run? I feel like it's only this one.
It only changes this one. It doesn't change this in any of this.
Thank you.
Sure, because these are a little, petals are a little full.
Why is it so, the research brother goes.
Time sure flies, doesn't it? Great job today. I'll see you next time on the quiz. I get over.
Thank you so much.
Ryan, we have a quiz.
Wait, yeah.
Okay. Guys, I don't think I can draw this graph.
You can draw it. Come on. What is that? I don't know.
Oh,
I love experimenting with Desmos and coming up with like really. Did you know you can also like make your graphs like sound? You can like sound your graph and stuff like that. Like, there's a function.
Sorry, there was no time expired.
Thank you. No, no, it's like my ring.
Yeah, my pleasure.
That was my favorite one.
I know.
You can make music in Desmos. That's right. I've seen people do it.